Okay, hello everybody. I hope that you are all having a wonderful afternoon so far. Um, my name's Arlinda. I am the CEO at Scholarly Elite Tutoring. We are an online and in-home tutoring service that offers tutoring throughout North America, but primarily in Ontario. If you are joining us for the first time, I hope that you will feel comfortable leaving any questions that you have in the chat. That's what the chat's for. And also, if you feel like your question cannot be properly told in the chat for whatever reason, like it has a graphing component or blah, 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 you're more than welcome to email us your question to the following address. Let me just put it here. Admin at Scholarly Elite. My writing looks a little bit crazy, but you get the gist of it. Admin at scholarlyelite.com, and I can answer it during the live stream. So, another thing I want to mention as well is that, oh my gosh, my brain just went out the window. Is that if that's what it was, is that if you actually have questions even pertaining to the stuff that we're working on today, again, you're more than welcome to leave them in the chat. That's really what this whole thing is about, is getting you guys the help that you need in the moment instead of having it just as a worksheet so that it's very interactive. Okay. Alrighty. So as I said last week and the week before, we are ramping up to wrap up freemathhelp.ca next week. Today's lesson that I have planned is going to be about trigonometric graphing and how that whole concept comes together in terms of actually understanding how to use it with word problems. So, as you can see, I've got a question here up on the screen. I'm just going to do a quick sound check to make sure you guys can hear me okay. Okay. Alrighty, so I'm just going to move everything down a little bit so I can put that info there for you guys to take a look at. If you do need to send in any questions, let's put it in blue. So that's our email address. And if you can also submit directly to the email address through our website as well. Okay, so today we are continuing our lesson or unit, I guess you could call it, on trigonometric graphing. As you might recall from previous weeks, trigonometric graphs basically encapsulate the visual representation of the sine function, the cos function, tan, cosecant, all of that stuff can be graphed. And the independent variable on the graph is usually x, and then the dependent variable is usually y. When we talk about word problems, the terminology that we use for x and y tends to change based on what the problem is asking us. And it's very important to understand how to properly frame the word problems in terms of the cos and sine functions. So, as we've learned the past couple weeks, and if you missed the past couple weeks of our freemathhelp.ca grade 11 classes, they are up on the YouTube channel where you're watching this. So our Scholarly Elite YouTube channel, you can go back and watch those at your leisure, just so that you can either get a better sense of what we're talking about here today, or just review if that's up to you though. Okay, so let's talk about this. When we have a sinusoidal function or a trigonometric function, but typically when I'm talking about sinusoidal functions, you're talking about a certain cycle that occurs over and over again at the same exact kind of temporal rhythm, I guess you could say. I know that's a fancy way of saying it. I couldn't think of another way. Um, and oftentimes these questions will be stuff about the tides, time. You'll see a lot of them that have to do with wheels because those things happen in the same format over and over again. So if we recall, we have a couple different pieces of each of our each of our equations. So whether you're talking about a sine or a cos function, you have your amplitude, which is the A term. You have your K term, which basically tells you your horizontal compression or stretch. And the D term tells you what's called a phase shift, which just means how far the equation has moved left or right. And the C term, which is the vertical shift. Okay, so keeping all of this in mind, if you recall, there are a couple of equations that we use to kind of ascertain exactly what it is that each of these terms needs to be written as. So for A, we've got our max minus the min, and usually that's in reference to the y value divided by 2. We've got the C term, which is max plus min divided by 2. And we've got the K term, which is 360 divided by the period. Yay. Okay, so let's read this question together and break down what it is exactly you need to look for in these types of questions and how you can develop a structure or a pattern that will help you break these down without ever really needing to think too much about it. Obviously, you want to think about it, but you don't want to waste time, right? So there's a method to the madness here. So part 1, at high tide, the water level at a particular boat dock is 9 feet deep. The low tide of the water, I wrote that wrong. The low tide of the water is 3 feet deep. On a certain day, the low tide occurs at 3 a.m. and the high tide occurs at 9 a.m. Find an equation for the height of the tide at time t, where t equals 3 a.m. Okay, so I'm going to tell you guys from my first look here, what I only really care about right now is line 1 and line 2, which I'm trying to, that's really ugly. So I'm just going to say this line and this line are the two that we care about. Now, what's important here? Well, they've actually told us our maximum and our minimum. So the way that we're going to write this equation, instead of it being y and x, we're going to say that this equation needs to be height as a function of time equals all of these things, and we don't know yet whether it's going to be a sine or a cos function. We're going to determine that, but I'm just going to arbitrarily use sine right now to illustrate my point, that this is not going to be x, it's going to be t, because t is going to be our independent variable. Time is typically your independent variable. Now, there are rare exceptions to that rule, but most of the time is going to be your independent. Now, again, like I said, we are not sure whether we're going to make this a cos or a sine function yet. We will determine that, TBD. But for now, I'm just going to write sine. That was mainly to illustrate that, instead of f of x, we write h of t, because height as a function of time, and then time is our independent. Now, let's plug some stuff in. I've got the a term, which is 9 minus 3 divided by 2, which is going to be 3. The c term, which is 9 plus 3 divided by 2, and that's going to be 6. Now, let's talk about the k term and what we're going to do to kind of figure everything out in this scenario. So let me just make sure I'm reading the right part here. Yeah, so basically, we can assume that this happens over a certain period of time. And what we're saying to ourselves is, if the low tide occurs at 3 a.m., okay, so let's just arbitrarily, this is not the thing, but let's say low tide is here, this is at 3 a.m., and the high tide is here, and this is at 9 a.m. That means that halfway through the cycle, from here to here, takes 6 hours. Which tells us that obviously there's another half of the cycle that happens later on. which tells us that the entire period of this function is 12 hours. So my k value is going to be 360 divided by 12. Now, this is the kind of question where a lot of people that I have tutored over the years tend to get confused as to how to determine the period. Again, sometimes the period isn't given to you in a straightforward manner. You have to kind of go in and use the clues that they've given you in the question to figure it out. So again, if you know that this is a sinusoidal function, from low tide to high tide is half of that period. And in general, from the minimum to the maximum is going to be half of a period. Okay? Now, let's get that number. So that's going to be 30. So I already have 3 pretty awesome information pieces here. I've got A, and I've got C and K. So let's plug those in. You know what? Let's just do this. There we go. Sorry guys, I'm having a bit of an allergy flare up today, so please don't mind my coughing. I don't have coronavirus as far as I know. So not that it matters because we're over the internet. It's not like I can give you coronavirus, but still, just got to be safe. Alrighty. So I've got all that information. Now, what I want to do is look again at the question and see whether or not it would be smart to use a sine function or a cosine function. Okay, so if I was to use a cosine function, I have to go and start my cosine function at high tide. Why? Because cosine functions always start at the maximum value. So in this case, and in cases similar to this, where you've been given the maximum, but you haven't been told what the C term is necessarily, even though now we've determined it, that it's 6. But in this case, they've told you exactly when high tide occurs. So in my mind, I think that using a cosine function would actually be quite simple because it's already given you that information. So I'm going to use a cosine function. And this D term is going to now become plus 9. Or sorry, minus 9. Minus 9. The reason it's minus 9 is because our standard function for cos or sine is, like you can see here, a sine or a cos bracket or parentheses k bracket x minus d bracket, close bracket, yada, yada, yada. So because our typical function has the negative in it, that means that when I use a positive value like 9, because time is linear, it's going to be positive, right? There's no negative, technically there's no negative time. Although some physicists might disagree that time, obviously, in actuality, time is not linear. I'm not going to get into a whole discussion about it, but let's argue that for the sake of this question, time is linear, right? And that we're not theoretical physicists and we're not going to get into all that stuff. Time in this case is positive. Therefore, because the typical sine and cos equation has the negative value in its formula, that means that a negative times a positive is going to be negative and it stays negative. Okay? If that's confusing you, just let me know. I can elaborate further, but I don't want to like bore you guys with jargon if it's not confusing anybody. Anyways, so this is our final answer, you guys. Now, these questions, actually, this unit tends to be the lowest scoring unit in general from what I've seen from various marks and tests and stuff like that. And I do think it's because they typically, from what I've seen, teachers don't walk through these step by step. They kind of teach you guys a lesson and then let you figure out word problems on your own. And I find that that's not enough practice. So yeah. Okay, so I'm going to leave that up for like 2 seconds and then we can do another example so that we can try it out. Oh, we didn't answer the second part of the question. Sorry, guys. Let's do that. Oh my god. Okay, there we go. What's a good complementary color? I think that's nice, this pinkish. Anyways, okay. So they want to know what is the height of the water at 2 p.m. Well, 2 p.m. is technically 14 if you follow like the European or army time or whatever it's called. So 14 is what we're going to plug in as time. So we can just go ahead and do that. We get h of t actually, it's not h of t, it's h of 14 equals 3 cos 30 14. God, what am I doing? One thing I will say, if you're following along and doing this on your calculator, please, please, please make sure that you go to your mode on your calculator. Make sure that your calculator is in degrees, or else this is not going to get you the right answer. In grade 12, you're going to make sure that your calculator is in radians, but right now we're sticking with degrees. So obviously this breaks down a little bit further. We get 30 times 5 plus 6. So this becomes 3 times cos of 30, no, not 35. What am I talking about? 30 times 5, which is 150. Cos of 150, which is technically degrees, plus 6. So let's plug that into our calculators. Cos of 150 degrees. So in terms of the bed mass of this type of question, remember that you're going to want to do the cosine function first. Think of it as being in brackets. So that's why we do that. Okay, so we get cosine function answer first, then times 3 plus 6, and we get 3.4. And that is the water level, so that's going to be in feet in this case, because I apparently didn't change it to meters when I was typing out the question. And that's our answer. So obviously that's not too crazy to do, but I wanted us to do this question first so that I could show you guys this, that you want to do this part first, and then again this part first, and then multiply that answer by 3, and then add 6. Because obviously we're following bedmass, but then a lot of times people are like, well, how do you incorporate cos and sine into bedmass? My answer is do the cos or the sine thing first. I can't think of the word I'm trying to think of. Do the cos or sine operation first, and then multiply, add, blah, blah, blah. Okay? All right, my good friends, let us move on. So I had intended to type out all these questions, and then I had a couple of parents call me when I was on my break, so I didn't get a chance to actually do that. So I apologize, you guys. I'm going to be typing them as we go along, but just bear with me, okay? So, wow, that's very pink when you type it in words. Let's make it black again. Okay, so let's look here. Wow, it's still pink. You know what? New one. The average depth of water at the end of a dock, it's another depth one, so you guys know, is 6 feet, but it's going to be different in terms of what the follow-up question is, so that's why I want us to try this one as well. Is 6 feet. This varies 2 feet in both directions with the tide. Suppose there is a high tide at 4 a.m. And actually, if you guys are following along, I would highly recommend copying these down, because the more examples you have of this, honestly, the way easier it is for you to do that, to do this on your own later. So if the tide goes from low to high every 6 hours, write a cosine function, which this is cool. It's telling us specifically which one to write. Take some of the guesswork out for us. Describing the depth of the water as a function of time with t equals 4 corresponding to 4 a.m. At what 2 times within 1 cycle is the tide at a depth of 5 feet? Okay, this question is the kind of question that you will see on pretty much every test of this unit. Because this unit does repeat itself in grade 12, I highly recommend, again, copying down how I'm about to do this, because it's quite popular to see this. It's quite common to see this type of question. Sorry, my gamer headphones are killing me. Let me just fix them. I honestly, you guys who are gamers, I give you guys my hand. I don't know how you wear these headphones all day. They drive me nuts. Just in the 4 hours that I wear them for freemathhelp.ca, they drive me crazy. Kudos to you guys for being able to do it. And this time we're actually going to show it on a graph as well. but the first time I just wanted to show you guys the steps. So again, let's write out what our standard cosine function is. Ya cos k bracket x minus d plus c. Okay. Again, I'm going to take some fun colors here. Let's do blue. Okay. So it says here the average depth of water at the end of the dock is 6 feet. What's really great about when they tell you the average is that they're telling you the C term. So kind of keep that in the back of your mind as just being something to look for, because it's actually just already giving you the answer. So that can just be my C term right away. Oh, 6. There we go. This varies 2 feet in both directions. And the reason why we know then that it's a C term is because it does tell you that that's the absolute middle. That's our axis of symmetry in this case. So it's varying in 2 feet in both directions. Therefore, my maximum obviously must be 8. Or I don't know how obvious it is, but that's what it is. And then my minimum is going to be 4. So I can actually check that my C term is correct by just going max plus min divided by 2. And obviously that does equal 6. So that's correct. Then my A term can be determined 8 minus 4 divided by 2. And I'm going to get 2. So already I've got 2 pieces of the puzzle. Now let's go to the next point. They're saying, suppose there is a high tide at 4 a.m. So again, I'm just going to kind of arbitrarily draw this. This is at 4 a.m. And if the tide goes from low to high every 6 hours, then this obviously has to be at 10 a.m. Unless my ability to tell time has gone away. You never know, it probably has. So they've actually told us what half of the period is again. So the period must be 6 times 2, which is 12, obviously. And we're going to go ahead and figure out our k value, which is 360 divided by 12 again. It's going to be 30. Now, we can put this all together and get ourselves a nice little cosine function. So we've got 6. Oh, I lied. 2 cos bracket 30 x minus. Now, this is where it gets interesting. We need to determine what is the value of the d term. Now, we know that there is a high tide at 4 a.m. So that tells me that my d term is going to be 4. Because I'm using a cos function, I only care about what the high tide is in this particular instance. So there we go. This is the part A of the question. This is here. This is the answer to this part. Okay. Now, to get the next part of this answer is where it gets interesting. So I'm going to use this reddish color. At what 2 times within one cycle is the tide at a depth of 5 feet? So this is where it gets interesting, you guys. And this is where I want us to be really aware of the fact that cosine and sine functions, when we're graphing them in terms of trigonometric graphing, it's not really removed from our understanding of the unit circle. And when we understand that the unit circle and this are basically telling us very similar, if not the same thing realistically, it makes our job a lot easier. So as we know from the unit circle, which I'm going to open on another page just so I can illustrate what I'm talking about. So here's the unit circle, super cute, nice and dandy looking, love it. Okay, let's talk about, let's use the concept of 30 degrees, just I'm picking that arbitrarily, okay? So what I'm trying to show you guys is this. If we remember that the unit circle is a collection of points on the circle, obviously, and we can consider this value x and this value y, but more accurately, we would call them cosine and sine. One way to remember that, as I've said before, is that they are alphabetical. So if this is cosine and this is sine, right? If I look at 30 degrees right here, not too shabby, not the straightest line, but it's better than I've done before. So if we look at cosine and sine, cosine is root 3 over 2, sine is a half. If I now look at this angle, which is 150 degrees, this line is not going to be as straight, but you guys get what I'm getting at. So 150 degrees is 30 degrees off of 180, right? It's 180 minus 30. So As you can see here, because it's in this quadrant, the second quadrant, the cosine is negative. It's negative 3 over 2. And the sine is a half. So all of this is to show you that this is cyclic, right? It repeats itself. We have 30 degrees, which is 30 degrees from 0, right? Off of the x-axis, it's 30 degrees up. We have 150 degrees, which is also 30 degrees off of the other side of the x-axis. Again, if you look at this one, 210, it's 30 degrees plus 180 degrees. But again, it's 30 degrees off of the x-axis. Okay? So keep this in mind. Okay, I'm not gonna, there we go. Again, this happens a bunch of times. So that's kind of what they're insinuating in this question that we're solving here, is that obviously because this is cyclic and because it follows that same type of structure that the unit circle follows, we can use that information to our advantage. So at what 2 times within one cycle is the tide at a depth of 5 feet? Well, first of all, we need to determine how we should have actually written this equation. So this equation is depth as a function of time. So I should have really written it in this format. D as a function of time equals 2 cos parentheses 30 bracket t minus 4 bracket plus 6. On a test, if you guys don't put it in this format, now again, it varies based on your teacher. You guys all go to different schools, I'm assuming, et cetera, et cetera. But in university, for sure, you will lose marks because this is also part of most first year calculus courses, especially if you're taking like a health sciences, biosci, any type of non-business calculus, because the business calculus doesn't really use this. Most business stuff is not cyclical in this way. So anyways, just be aware of that, okay, guys? I don't want you to lose marks for something silly. So anyways, okay, at what 2 times within one cycle is the tide at a depth of 5 feet? So what they're really asking is to make the 5 as our y value or as our d of t value, and then solve from there, okay? So this is kind of what they're asking, is for us to algebraically solve for time. But because it's a cyclic function, there will be 2 answers. Okay, so let's go ahead and start doing this algebraically. Again, I'm just going to copy this here. So 5 equals 2 cos 30 t minus 4. And I know for some people it's been a while since they've done like straight up algebra. I always used to teach my younger students that algebra is just BEDMAS backwards. So what do we do first? Well, we first start with subtraction and addition. So we go ahead and move the 6 over. So let's do that. So 5 minus 6 equals this, 2 cos 30 times t minus 4. Next, I'm going to divide that by dos, because obviously I've got this 2 times cos situation. So divide by 2 on both sides. So that leaves me with this canceling. So I get 5 minus 6 divided by 2 equals, sorry, I just wanted to make sure of something, equals cos and then 30 t minus 4. Okay, so where do we go from here? Couple things happen here. And I want to make sure that we're going through this very specifically so that if you guys have any questions, you're more than welcome to ask, and so we can actually get to the crux of what's going on here. So in this case, we know that right now we have cos times technically this whole situation here, but I have an unknown variable in there. So that makes it kind of annoying for the purposes of what I need to do. So first of all, I need to simplify 5 minus 6 divided by 2, which is going to be negative a half, which is very interesting to me as a person who knows the unit circle. Obviously, I don't know it off by heart, but if we memorize those special triangles I always talk about, you will know the unit circle off by heart. Especially when you're in grade 11, it's really great to memorize them. So, okay, anyways, to the point. So the point is that now I'm going to technically divide off cos, and I'm going to show you what I mean. So I have cos here. I'm technically dividing off cos. And it's like, yo, you can actually do that? Yes, you can. No one ever talks about it though, but this is really what's happening. I'm dividing cos off of both of these things. Okay. But what's really happening when I'm doing that is that on this side, I have cos to the power of 1 being divided. Okay, let me move this up a bit so we can see. Now, given that information, if we recall that when something is on the wrong side of a denominator, it has, a wrong side of a fraction, it has a negative exponent. So therefore, when I move this up to the top part, I'm going to get cos to the negative 1, which if we remember from grade 10, is a great way to solve for angles. So now I'm left with on this side 30 and t minus 4. Okay. So now let's go back to the unit circle. Let's take a look at let's take a look at what values or at which degree values cos is negative a half. So we've got over here, cos is negative a half at 120 degrees, right here. And cos is also negative a half at 240 degrees, right there. So 120 and 240. You can also technically put it into your calculator if you really wanted to. You just go shift cos negative 0.5, and it will tell you 120 as well, as long as you're in degrees. But again, we've got the unit circle. Why not use it to our advantage? More visual. So now I have two different values that I can use. So this is true at both 120 degrees and 240 degrees. So now I need to split these up and solve them separately. That's the whole situation. Okay, guys? So let's go ahead and do that. Now, So let's try 120 degrees. So 120 degrees, because I've now replaced cos to the negative 1 times negative a half by 120, equals 30 times t minus 4. And all I need to do is solve algebraically. So I'm going to divide by 30, divide by 30 equals 4, t minus 4. Oh, hold on a second. Sorry, guys, I just want to make sure I'm giving you the right piece here. 80. Oh, okay. Sorry. I was like literally my arithmetic got me messed up there. Okay. We're good. I was doing the right thing the whole time. We're fine. So t equals 4 plus 4. And that means one answer for t is 8. So now let's use that same logic and use 240 degrees, because again, it's also accurate for 240 degrees. This is degrees as well. So then I get 30 times t minus 4. Again, same concept. Divide. Oh, not the right slash. There we go. So 240 divided by 30 is 8. So then we get 8 equals t minus 4 and t equals 12. So t equals 8 and t equals 12 are both correct in this instance. So let's go back up to look at what the question was. So it said, at what 2 times within one cycle is the tide at a depth of 5 feet? So again, I just want us to reiterate what we did here, okay? Because they're telling us that they're asking for the depth, we know that they're asking for what we usually refer to as the y value. So you put that in its correct spot, you solve algebraically up until the point you get to cos, which again, you're still going to solve algebraically, but you divide cos off of both sides, which leaves you with cos to the negative 1. and it's going to let you solve for angles. So you solve for which angles that is true by using the unit circle or your knowledge of the unit circle. So if you don't have a unit circle in front of you on a test, you know that because your calculator is only going to give you the answer 120, right? So in order to circumvent that, what you're going to do is remind yourself, well, if 120 is 60 degrees less than 180, then I also need to know what is 60 degrees more than 180, because I know that in quadrants 2 and 3, as you can see here in quadrants 2 and 3, I have a negative cos value. Okay? So yeah, that's another thing that, like, when you're given this on a test and you don't have the unit circle, that's where a lot of people get really stumped and they really get freaked out. Don't get freaked out. Just remind yourself your knowledge of the unit circle, understanding of, like, what does cos really mean? What does sine really mean? And then solve from there. So here we got our answers. T equals 8 and T equals 12. Yay! Now let's do the last piece that I promised, which is actually doing like a little graph. I'm not going to do a fancy graph. I'm just going to show you guys kind of how it would look in terms of spacing. So since I've got my function here, I'm just going to erase this part. Since I've got my function here, I'm going to show you guys what I mean. So if I was just drawing this graph kind of for the sake of drawing it, or, you know, say the teacher asked me to draw a little sketch of the graph, I would have this like this. Again, because it's time, I'm not drawing the negative part for now, especially because they told me the time starts at 0 in this case. If you have, like, you know, time when time is a year and you started in March, but you know that there were data points in January and February, you have to draw that as the negative, if you will. It depends, right? So again, let's take a look here. I'm going to make sure that my points kind of make sense. So if I know that my max is 8, I'm going to put 8 and then 6, 4, 2. So there's 8, 6, 4. I know that this is my, like, axis of symmetry. I know that this is a cos function. So obviously that matters as well. But because even though it's a cos function, doesn't mean that when I'm showing it on my graph, it's going to literally start at 0. In this case, it starts at 4. So I'm going to have to indicate that. So 4. So this is 4. Okay. This is 0. And here I would write time and depth as a function of time. And then I'll just plug some points in. So if I know my cos function starts at 8, I know that it goes to 4 by the 10 points. So 5, 6, 7, 8, 9, 10. So here I know that it goes to 4. And again, if you weren't given all this information in the question, it's fine. You can solve it once you know the actual equation of the graph. So we've got that. And here we are. Now, basically, you also know that, where'd it go? There it is. It's going to reach that 6 value right at 7. So I would show, again, because I'm just kind of doing this to show you guys, but it doesn't need to be perfect in terms of how fancy it looks. But again, if your teacher asks you to sketch, this is kind of what I would suggest. Just a quick sketch with all of your main values. You don't, unless they're asking you to sketch 2 cycles, then you go ahead and plug everything in. But for now, this is more than enough. And how do I know that 7 is going to be at my middle point, like at t equals 7? Well, if you think about it, 7 minus 4 is going to be 3. 3 times 30 is 90. 90 times, or cos of 90 is 0. So that's how I know. So 0 times 2 plus 6 is going to be 6. Okay. Alrighty, you guys. So this was quite a doozy of a question, but that's why we chose this one today, because, or as one of the questions today, because it really is at the at the core of what you need to understand for this whole unit to kind of come together for you. All right. So if no one has any questions about that, I'm going to move on to another one. If you have any questions about kind of the structure of how I solve these questions or how I've been solving them, please feel free to ask. I'm more than happy to answer. But in general, as long as you follow these same steps over and over again, and then you get really good at understanding what to look for and what to plug in, you'll be fine. Okay. So I don't see any questions, so we're just going to keep trucking on forward. Let's do this. So okay. This is an interesting one. So a city averages 14 hours of daylight in June, 10 in December, and 12 in both March and September. Assume that the number of hours of daylight varies sinusoidally over a period of 1 year. Write an equation. Oh, the question says expression, my bad. For n, the number of hours of daylight as a cosine function. They really love the cosine function on this for some reason, of t. And let t be in months, which is important. And, you know, if they don't tell you that and they've given you a question like this, typically it would be in months. But, you know, if you get a question like this from your teacher and you're not sure, feel free to clarify with them. What is the average amount of daylight hours in August? Okay, I should have done this. There we go. Cool. Yay. And it always does this. It drives me nuts. I think it's because of this. No, it's not. That's annoying. That's okay. We can deal. Alrighty. So let's talk about what's been told, what hasn't been told, and how we can, or hasn't been told to us, and what we can do about it. So a city averages 14 hours of daylight in June, 10 in December, and 12 in both March and September. So given this information, I can kind of assume a couple of things. First of all, we know that 14 hours is our maximum. So let's put that up here. And we know that our minimum is 10. And actually, we've also been told our C value. We've been told the axis of symmetry because, as you can see, first of all, obviously, we'll be able to figure that out if we want. But as you can see, if it's happening twice for the most part, and it's perfectly smack dab in the middle of these other two numbers, you know that that's going to be your C value. But again, we can determine that if we want. So 14 minus 10 divided by 2 is just going to be 2. The C value is 14 plus 10 divided by 2, which is 12, which makes sense because we already knew that. Now, assume that the number of hours of daylight varies sinusoidally over a period of 1 year. Therefore, it is a function that has a period, and they want us to write an expression for n, the number of hours of daylight, as a cosine function of time. So therefore, our function is going to be in the format of number of hours of daylight as a function of time equals a times cos bracket k t minus d plus c. Okay, given all of this information, one thing I don't know yet, or I haven't solved for yet, is the words. Wow, my brain. is the k value. Now, we know that this happens over the span of 1 year. We know that time is our independent variable. Therefore, I'm going to use the number 12 as my period. So if k is equal to 360 degrees divided by the period, then that's what we get. So again, it's 30. I don't know why they've made all these answers 30. I just, this practice set of questions was the best one I found. In terms of like having a good variability between the types of secondary questions that they ask. So that's why I chose this, but I was not aware that they made all of the k values 30. Regardless, it's okay. We are strong. We can figure it out. So we've been given a bunch of information here. One thing we also need to ask ourselves is, because this is a cos function, at what point does our thing happen? Our what's it called? Oh my god, my brain. Our maximum, because that's what's going to matter. So one thing I will do before we get started in terms of the second, oh, that shouldn't be like that. Be like this. So before we get started, one thing I want us to kind of think about is the following. So typically you would think of June as the 6th month, but in this instance, you're not going to, because January has been given to us as t equals 0. So then I have to go, 1 is February, 2 is March, 3 is April. Am I even saying the months in the right order? Yes. Okay, good. 1, 2, 3, 4. Sorry, 4 is May, and June is 5. So be really careful with these kind of questions in terms of what they tell you they want to correspond to t equals 0, because it will change how you approach the question. So June, July, August, September, October, November. Am I missing one? No, we're good. December, and back to January. And then we've got our hours. So we've got like 10 and 12 and 14. Well, so they want to know, what is the average amount of hours in August? There's a couple different ways you can solve that. First of all, I want us to graph this before we do anything else. So I know that my maximum happens at in the 5th month. So that's here. Oh, sorry guys, I didn't actually put the equation together. So the equation is n of t equals a cosine 30 t minus 5. Again, because in this case, 5 is positive. Also, if you think about it, we are kind of thinking of shifting the cos function in the positive realm. And remember that we always use the opposite sign. Okay, plus 12. Okay, great. So, so we've got 14. I know that 12 is my middle point. Got to plug that in. So at m equals 2. So we know that in March and September, it's at 12. Obviously, it has to go to its low point at some point. That would be here. And then we come on back over here. So clearly, here's our cos function. Now let's talk about what we would, before we answer the second part of this question, let's discuss what would this function be as a sine function? Well, if you think about it, if it was a sine function, it would start here, because that's the middle. My points are not that good, but you guys get what I'm getting at. Because sine functions always start at the axis of symmetry. They typically go upwards unless they're a negative sine function. So in this case, my sine function would be a sine, still 30, because remember, everything else stays the same basically. Not basically, like in actuality, everything else stays the same. The only thing that changes is the phase shift. So if this was a sine function, that's what it would look like. Again, these two things if you were to plug both of these things into Desmos, if I did them correctly, which I'm assuming I did, they would be the same graph. That's really important to understand. And that's something that a lot of kids, when they do come for tutoring with us, like that was never explained realistically. Like teachers kind of sometimes talk about it as being, here's a cos function, here's a sine function. They the same. You just have to know how to differentiate between the two of them in terms of the phase shift. Okay, cool. So let's keep going. Now we want to know what is the average amount of hours, of daylight hours, in August. I am going to first and foremost figure out which month August is based on my weird definition of the months. So August is the 7th month. So I'm just literally going to say n of t. Oh, I lied. Not n of t. So the number of daylight hours at 7, at the time of 7. God, my brain. Okay, here we go. A. Guys, what's wrong with me? I keep writing A instead of the number that I'm supposed to write. Even here I wrote it wrong. 2. This is also 2. This should be 2. There we go. Okay, 2 cos bracket 30. T minus 5. In this case, T is going to be 7. Wow, guys, what's wrong with me? There we go. Cool. Usually I complain on here about not having enough caffeine. I think today I'm over caffeinated. I don't know what's wrong with me other than that. I'm assuming it's just the going ham on my coffee today. Okay, so here I get 60, so the cos of 60 degrees. Again, remember that we're doing this kind of not backwards, but starting here, then multiplying by this, then doing this. Okay, so let's look at the unit circle. The cos of 60 degrees is a half. So this can be changed to 2 times 1/2 plus 12. And that's going to equal 12 plus 1, which is 13. Yes. So the average amount of daylight hours in August is 13 hours. Okay, I'm going to leave that up for a second. If anyone has questions, you're more than welcome to ask them. Again, if anyone is just popping in, I do want to remind you guys that next week is going to be our final week of freemathhelp.ca. So if you have questions that you want us to answer, you can either submit them to our website. Where'd it go? Our website is scholarlyelite.com, or you can email them to us at admin@scholarlyelite.com. And for those of you who might have been here when I was talking about, like, we just launched a new website, go give the website, go say hi to the website. It took me a long time to make, you guys. It took me a really long time. And I'm not a tech person. So, not that I'm going to say I'm proud of myself, but like, it was quite a feat. JK, I didn't do any coding. It's a Wix website, but still it takes a super long time to put a website together, even if you're not coding it. I can't imagine if you're coding it from scratch. Okay. Coolio. Let's try another example. If we actually we have like 7 minutes left. Let me find a quick example. We're gonna do this one because it's quick, and also I like that it's a different type of question in terms of like what the content of the question is about. To do. So Ruby has a pulse of 73 beats per minute and a blood pressure of 121 over 85. If Ruby's blood, I love the name Ruby, by the way. Pressure can be modeling. Okay, sorry, I stopped reading it. So if Ruby's blood pressure can be modeled by a sinusoidal function, find an equation of this sinusoid. And I picked this question because I like the word sinusoid. I think it's funny sounding. the sinusoid. So let's find it. Let's solve this bad boy. Let's talk about max and min. In this case, we are going to assume that blood pressure is her y value, making 121 the max, and making the min 85. And then I'm also going to assume that 73 is our period, because it's saying that she has 73 beats per minute. And for those of us who might not be familiar with blood pressure is very much related to your heart rate. So, I mean, it's a little bit more complicated than that, but for the purposes of this question, that's what we're going to use as our indicator, basically. So we've got a period of 73. So now, why am I not using 1 minute as our thingamabob? What's the word? As our period? Well, because what we really care about is how the blood pressure is affected by how many beats per minute are occurring. Okay? Because it didn't say how many minutes it occurs over, right? Like, it's not saying that the blood pressure is a function of the minutes. It's saying basically it's a function of the beats per minute. Anyways, okay, not to bore you guys, let's go ahead and plug some numeros in. So 121 minus 85 divided by 2 is going to be 18. And 121 plus 85 over 2 is going to be 103. K is going to be 360 divided by 73. Cool. So now I'm just going to leave that as a fraction for right now to make life easier. Let's start plugging stuff in. They did not tell us whether it's a sine function necessarily. Like, both sine and cos are sinusoidal functions. So therefore, when they tell us to solve for a sinusoidal function, we cannot just assume that it's cos or sine or whatever. I'm gonna use sine in this case just to make life easier, because I personally like making sine functions better. But again, you could have made this a cos function. So let's plug some numbers in. Y equals 18 sine bracket. I'm just going to leave this like this, 360, 73. And I'm going to assume that at time equals 0, this starts at the midpoint. So I'm actually not going to make a shift in this particular instance. And then I'm just going to have my vertical shift of 103. And that's the answer. Whoa. So yeah. Alrighty, you guys. Now, how can I know that I'm correct in choosing this as a sine function? Well, if it's 73 beats per minute, a couple things we can do. Well, at the end of the minute, right? Or at the end of that amount, we'll reach 73. So that means that when we're back at where we need to be in terms of the sine function, right? Because the sine function would look like this, that the answer should be 0. So realistically, this would be 18 sine, or what is it? F of 73 equals 18 sine times 360 over 73 times 73. This should be square. Plus 103. And then those cancel. And if we remember, the sine of 360 is 0. So this makes this 18 times 0. Whoa. Plus 103. And we know that 103, or we can ascertain that 103 is our midpoint. And that's where we at. Okay, great. So guys, that's the wrap for the second last week of our grade 11 freemathhelp.ca. I hope you guys enjoyed this. I hope this was helpful for you. If you have follow-up questions that you want me to cover next week, let me know. If you have random questions that you want me to cover next week, also let me know. So, wishing you all an amazing weekend ahead. Stay safe out there. Have an awesome day today. And hopefully, I'll see you again next week for our last session on freemathhelp.ca. So, thank you guys and have a good one. And if you're here for the grade 12 class, just give me 1 second to grab my grade 12 materials here and we can get this show on the road. And if you're here for the grade 12 class and you wish to ask a question, let me know. You can send it in the chat or you can send it to our email address, which is not on the screen anymore, but we can put it up. admin@scholarlyelite.com. All right. So, just grabbing some grade 12 materials here. Okay, guys. Just a minute. And again, if you're here for grade 12 and you have questions, like I said, feel free to leave them in the box below in the chat box. So I actually had someone submit that they were hoping we could cover optimization questions and things in that realm for calculus. So we are going to do that. I know that on the announcement we said that we were going to talk about what's the word? Parametric equations, which if we have time we will. But just to let you guys know. Okay, just give me 1 second, guys. So, sorry guys, I had an optimization question, now I can't find it. Just give me 1 second. We shall cover it, I promise. Okay. So when we talk about solving an optimization problem, really what they're asking for is determining the maximum of the maximum value of the function and determining the global maximum, right? So when we talk about optimization, we need to determine all of this information using our derivative. So the first things that we want to do when we're solving an optimization question is to find the derivative of the function, which is the function f of x, and then determine if there's any potential local maxes or mins by setting f prime of x to 0. So let's go ahead and start with this question. I'm just going to erase this because this looks like chicken scratch. Okay. So a wire with a length of 30 centimeters is cut into 2 pieces. One piece is bent into the shape of a square. The other piece is bent into the shape of a rectangle whose length is twice its width. The relationship between the lengths of wire for the 2 shapes is given by 30 equals 4x plus 6y, in which x is the width of the square and y is the width of the rectangle. Both in meters. Super important that they're both of the same unit. The sum of the areas of the square, and the rectangle is given by A equals x squared, x to the power of 2. You know what, I'm just going to write that because that's going to look wonky. The sum is also a minimum. Okay. So, let's talk about this question. I'll give you guys a second to read it if you're following along. I don't know why the Blue's Clues like Blue Skidoo, we can too. That's been in my head all day. I don't have children, nor do I hang out with children, so I don't know why. Alrighty, let's take a look here. So, a wire with a length of 30 centimeters is cut into 2 pieces. One piece is bent into the shape of a square. The other piece is bent into the shape, shape, God, of a rectangle whose length is twice its width. So, the relationship between the lengths of wire for the 2 shapes is given by 30 equals 4x plus 6y, in which x is the width of the square and y is the width of the rectangle, both in meters. The sum of the areas of the square and the rectangle is given by A equals, and I should write that in now. Let me put this here. A equals x squared plus 2y squared. So how do we solve this type of question? Well, first we need to make our let statements. If we remember back to grade 9, we always have to have our let statements. So let x equal the length of the side of the square. And we're going to let y equal the length of the width of the rectangle. Takes forever to write this, sorry guys. Now, so we know that the rectangle has a length twice its width. So that's going to be 2y equals the length of the rectangle. Okay, let's keep going. So we have the following. Because again, remember that x is the width of the square and y is the width of the rectangle. Now let's put everything in terms of y. So if I know that I can rewrite x as 2y, then that's great. I can plug that in. So I'm going to put that ahead. I'm going to go ahead and do that. So I'm going to have 30 equals, oh wait, sorry. Give me 1 second, you guys. Oh, what I mean to say is that we can break this down like this. 4x plus 2 times 2y plus 2 times y. So that's the same thing as saying 30 equals 6x plus, oh, sorry, 4x. Just write that again. 30 equals 4x plus 6y. Coolio. So now we're going to go ahead and rearrange this in terms of y. So I'm going to get 6y equals 30 minus 4x. And then we're going to simplify it by dividing everything by 2. So I'm just going to get 3y equals 15 minus 2x. And I'm going to divide 3 off of both sides. And that's going to leave me, let me move this up a bit so we can see. That's going to leave us here with y equals 5 minus 2 over 3x. And if you want to put it into the y equals mx plus b form, you can switch those around. So the total area equation is going to be x, well, we know it's x squared. And if we move back up to see like what the question was saying, x squared plus 2y squared. Okay. So let me write that here. So we can replace y with 5 minus 2 over 3x. So we're going to get that here. So we're going to go x squared plus 2 times 5 minus 2 over 3x squared. And that's going to give us, through FOIL, I'm going to give the decimal version here. So x squared plus 2 times 25 minus 6.7x plus 40, oh, sorry, 0.44, 0.44, I should say, x squared. And then that's going to be, when I bring everything together and multiply that in, it's going to be x squared plus 50 minus 13.14x and plus 0.88x squared. And I'm going to get, when I rearrange this, right, because we got to make sure that it's all rearranged, it's going to be 1.88x squared minus 13.14x plus 50. Okay. So now we've gotten to this point. Lord knows we ain't done yet. So let's keep on going, you guys. We need to find the minimum by finding the axis of symmetry. So if you recall, when we've got a situation like this is a quadratic equation. So the axis of symmetry is negative b divided by 2a. So I'm going to go ahead and plug in my numbers here. Negative 13.14 divided by 2 times 1.88. And that's going to be 3.5 when we round it. So basically 3.5 centimeters is the side of the square for the minimum area. So therefore 4 times 3.5, because it's a square, right? So we're timesing it by 4, is equal to 14 centimeters. And is the piece made into the square. So now we need to find the piece of the wire that was made into the rectangle. So piece made into square. Okay, let's find the piece made into the rectangle. So if we've got that information, we're going to find the piece made into the rectangle by using the equation that we had up here. So excuse me, guys. So this equation, y equals 5 minus 2 over 3x. Because if you recall, that's the equation we solved for earlier. So 5 minus 2 over 3 times 3.5 equals 7 divided by 3. Yeah, so 5 minus 7 divided by 3, which is going to give us y equals 2.66 centimeters, which is the width of the rectangle. And y equals the rectangle, therefore 6 times 2.66 is approximately 16 centimeters, which is the piece made into the rectangle. Okay, you guys. So I had something come through to me that's quite urgent. And I would not be asking this if it wasn't. So if anyone has questions, please let me know in the next minute or so. If not, I'm gonna have to shut down the stream and address this thing that just got sent to me. So again, I'm sorry, but if there is a question that you guys have, I'm happy to answer it before I go. So I'm gonna let this up for like a minute, and then yeah, then we can go from there. So let me know if you have a question, whether about this or about any other grade 12 topic. And then if you don't, and if no one does, I will see you guys again next week, same time, same place, for our final week of freemathhelp.ca. Okay. Alrighty, it doesn't look like we have any questions, but if you guys do in the span of this week, let me know. And actually, anyone who's watching that does have a question as a result of this not being the full time, I will, if you're watching live right now, not if you're watching on YouTube later, but if you're watching it live right now, send me your question, and actually, I can set you up with one of our tutors for a free 1 hour session to make up for the fact that I had to leave early today. Okay, you guys? So thank you very much. I hope you have an awesome week, and I will see you again next week, okay? Have a good one. Stay safe out there, and best of luck with the end of the semester. So have a good one, guys. Bye.